Hi, this is Ambush Chalapa here. I'm going to explain about my project for my pattern recognition coursework. So this project is shape recognition to identify irregularities during IC fabrication. So why do we need shape recognition? So consider any image you have. So in any image, to process the image and to do some kind of operations on the image, you need to find the shapes in the image, and if they have moved. So consider a room where you're going to monitor the room's operation using computer image processing technique. So in that case, you'll have a camera in some part of the room, and consider if there's any moving objects in the room. So to identify an object first, you should have shape recognition. So shape recognition is an upcoming technology in the case of image processing, and so I have chosen shape recognition as the basic concept. And why do we need it on IC fabrication? IC fabrication is a process which involves a lot of money in it. So in the case of IC fabrication, if you start the fabrication process, then you can't make any changes during the course of the process, or once the fabrication is done, it's going to be a huge amount of money invested in the fabrication process, and if there are any glitches in the fabrication design, it might cause a huge problem. So using shape recognition to identify irregularities in the project would be a great idea, because it would help you save a lot of money, which human techniques cannot find, because human eye is error prone and human techniques are error prone. So computer based image processing or pattern recognition to find irregularities in IC fabrication should be a pretty good idea. So what are we going to do? So in this project, I'm going to use image shape recognition technique to find irregularities in image processing. So I'm going to explain how shape recognition generally works, and that could be extrapolated for IC fabrication techniques in the future. So I'm going to explain how basic shape recognition works, and that can be extrapolated for IC fabrication in the future. Initially, shape recognition can be done in two different ways, using computer vision operation and morphological operations. So in computer vision operations, you have a series of procedures that need to be followed. So the first step in this process is going to be converting the RGB image into HSL image for L channel, that is the lightness channel. You do this because using the L channel, the amount of data being processed is going to be pretty less when compared to the RGB standard, and this would reduce a huge amount of computation. And this technique would be really helpful, because you're just going to recognize the shape and not going to use any color operations in the project. So converting the RGB image into HSL image is going to be the first step, and this image shows the conversion from a RGB image in the left side to a HSL image in the right side. So once that is done, thresholding should be done. So outsourced thresholding technique is being used. So this thresholding technique would kind of differentiate between the background and the shape assets. So if you could see in the image, the left side is a HSL image and the right side is the thresholded image. So you could see the objects being highlighted by a white color and the background being set to be black. So this outsourced thresholding does this operation. So while doing this process, you might have small places where the color has been where the background hasn't been filled properly. So in the case, if you could zoom in and see in the place where I have highlighted, you will find white spots. So these spots are being filled using image filling techniques, where you fill in those spots with the background color, and thus a proper binary image is formed. So once that is done, you need to remove noises. Since it's a binary image, it's gonna be salt and pepper noise mostly. So median filtering is one of the best techniques to remove salt and pepper noise. So median filtering is applied on the image to remove the salt and pepper noise in the image. So in the image, these are the locations. The regions highlighted are the locations where you have salt and pepper noise, and that has been removed using median filtering. And once that is done, edge detection to detect the edges of the shapes are being done using Sobel filtering. So Sobel filtering is used to find the edges, and so in this image you could see the edges being detected using Sobel filtering. And once that is done, the edges are thinned using image thinning techniques, where the thickness of the edges are reduced so that you'll have a better discrimination between the background and the edges, which could be used for shape recognition. So in shape recognition, you use a concept called compactness, which is the ratio of the square of the perimeter to the area. So using this compactness factor, you find out the shapes that are being used. So in this case, if you see, you could see a square being detected using the compactness factor. The next technique is going to be morphological operations, where you perform a series of operations which are pretty similar to the computer vision operation, but using that operation you find out the shapes in a particular object. So let me show you the result and explain how that is done. So in this case, you have an input image which has different shapes in it. So in the morphological operation, you convert the input image into a grayscale image, and once that is done, you need to invert the grayscale. I mean, you need to convert the grayscale image to a binary image and then invert it to find the shapes, and then use the compactness factor to find out the shapes. So if you could see in the final output image, you have shapes such as a rectangle, square, and circle being detected, because you know the exact compactness factor for those images, and so those images are detected, and image shapes with irregularities are detected in this technique. Now let me show you the code and run the code for you. So this is the code used for my project, and in this code you initially convert the RGB image into a grayscale image over here, and once that is done, you convert the grayscale image into a binary image here, and after that you invert the binary image so that you'll have the shapes highlighted using white and the background with black. Once that is done, erosion is done to flatten the edges of the image, and after that morphological operation is done over here to determine the objects, and the objects that can be tested are highlighted in this case. Now let me run the code, and here you see the output that I showed you already. So this technique helps you detect shapes as such, and this technique could be extrapolated to a minute level of IC fabrication, where you detect a particular shape and see if it should be in this way, or has there been any irregularities. So this way you could find detect shapes and find the difference in the shape, and thus make the changes in the IC design before it's being fabricated. Thank you so much.